Well, ladies and gentlemen, it's my pleasure to be able to introduce William Lee and Roland Yu from Sophos, who are going to discuss the challenge of will Android Trojans, worms, or Rootkit survive in SEAndroid, and I've got $50 riding on yes. So, gentlemen, let's see if my money's good.
Yeah, thank you. I'm Roland. This is my colleague William. We are based in Australia. So, over the last few years, SEAndroid and the containerization has become the buzzword in the mobile security. So we choose them as our topic because a main goal of both is trying to minimize the damage of the malicious applications, intruders, and the vulnerabilities. So attempt to explain the fundamental information of them and their impacts. So moreover, we will show some weakness that even with this security enhancement, the device can be still infected, still have data stolen, and experience the exploration of vulnerabilities. So we will demonstrate their failures by using some popular examples, and we will talk about the evolution of threat in the near future before the conclusion. So why SEAndroid and containerization? So first of all, we'll give a quick summary of them, which is access control. So SEAndroid was released in version 4.3 in 2013 and merged into mainline in version 5. So it provides better access control to application data, resources, and system services. So the containerization was introduced by security vendors to be a component of mobile device management. It attempts to control the access to enterprise data. So a lot of customers, medias, enterprise, including Google itself, believe that after adoption of SEAndroid and containerization, they can significantly reduce the damage of malicious software, protect users from potential flaws or vulnerabilities. So is it true? Let's take a look at some statistics. So after SEAndroid was released in 2013, July, today we have over 60% device running with SEAndroid enabled. However, Sophos witnessed an increase of both Android malware and pull. So for example, in July 2013, we have recorded near 400K malware in total. After 1 year, the total number became 1 million. So 12 months later, we received another 1 million new malware samples. So at that time, SEAndroid has been released for over 2 years. Now I'm going to pass the next part to my colleague William.
Let me give you a quick overview of SEAndroid. Android is basically Linux operating system. It comes with discretionary access control by default. Each application in your device has its own user ID and group ID for isolation. For example, this system application has a system privilege, so it has a system UID and group ID. However, third-party browser application does not require any system privilege, so it has a normal UID and group ID. In addition to that, Android operating system introduced app permissions such as send SMS or internet connection. Only granted permissions are allowed. With DAC and app permissions, Android platform looks very secure. However, DAC mechanism has its own weaknesses. First, there is no system-wide security policy, but it has to rely on the file owner's discretion. Several problems have been reported. For example, the old version of Skype application created several files under apps folder. The files include several sensitive information, but the file was created with world read-writable access. All the third-party application was able to access the file. Second, flawed or malicious application can bypass permission system and they can escalate their privileges. So just on the DAC, there's no way to combine system daemons or send UID programs that runs with root permission. To tackle those problems, mandatory access control mechanism has been introduced. There is a system-wide security policy, and subjects such as application processes will be labeled with domain names. And subjects, including file system or system resources, will be labeled with class names. For example, when you run ps command with -c option in SEAndroid system, we can see the system security context information as long as with running processes. For example, setting application has system UID. Also, it is labeled with system app domain name. The third-party browser application has a user ID, but it is labeled with untrusted third-party application domain name. This particular security policy has followed certain format, for example, action, subject, and object and permission. For example, this one, app domain, which also include the untrusted third-party application, can access system folder, but only for read access permission. The following diagram shows the system architecture of SEAndroid. It has 3 components: kernel space, user space, and the security policy configuration files. Security server in kernel space load the security policy information and hook every single system call and make a decision. And the decisions will be cached. Also, system servers in user space like init or install-d also use the same policy information. For example, when you install your application, the install-d will check all the security policy, and the new application files will be labeled with new context information. Also, when you start a new application, Zygote process will poke and execute the new process, and the new process will be labeled with new context information. Android also introduced middleware mechanism for app permissions. For example, what we can do is the system application which is signed with system certificate, we can allow everything, every permissions. However, we can deny certain permissions for third-party application. Although Android has this mechanism, but Android 4.5 does not have any restriction on the third-party applications. So as long as the application permissions are granted by the user when the application is installed, all permissions are allowed. SEAndroid is not able to tackle all the security problems. However, SEAndroid can be a good solution for root exploit. For example, Gingerbreak, it is one of the well-known Android root exploit. It exploits system vulnerability and install hidden payload inside read-only system partition. But this family cannot survive with SEAndroid because we have a certain security policy. For example, this one. This security policy does not allow third-party app domain applications for read access for the system folder. Another example, Rage Against KZ. There's another root exploit, but this family cannot survive either because there's one specific security policy. App domain applications is not allowed to transit from third-party normal application privileges to system privileges. Okay, then let's talk about the second topic, containerization. Containerization was introduced by security vendors as an MDM solution. So you can use your personal device for enterprise application. For example, enterprise data, including business email, contact, or internet browser information, will be stored in separate, isolated, encrypted container. Only certified application can access those information inside a secure container, but not from the third-party application. But containerization technology also has its limitation because you can't install all the application like your favorite games or Facebook or Twitter inside a secure container. So it has also limitation. Android introduced many security enhancements like SE Linux or containerization technology, but they can't solve all the problems. My colleague, Laurent, will talk about those problems.
Okay, why is this security enhancement doomed to fail? Permissions are the key to control access in the Android. However, both enhancements didn't touch it. No matter in which platform, social engineering is most successful technicals. And SEAndroid trying to minimize damage of vulnerabilities. However, several recent vulnerabilities are able to bypass it. Capability in containerization is another big problem that may block other functionalities. There are many devices running with old versions like 4.3, 4.4 from known or unknown OEMs or customized Loom distributors. This gives an excellent environment for malware to survive. So we will demonstrate above factors in the following parts. This figure shows the classification of 1 million unique malware received by Sophos in the last 12 months. So premium SMS Sender is the largest malware family and owes over 50%. Malware Trojan holds the second position, followed by the Spyware. The rest of them are Rootkit, Ransomware, FakeAV. We're going to show how these malware families can survive in the security enhancement. So SMS Sender Trojan is the largest threat because this is the easiest way for criminals to make fast money. So the easiness can be divided into two ways. It requires only one permission, send SMS, and use send text message to silently send SMS. And it usually takes advantage of social engineering to be fake games, fake application, or porn video players. Let's take a quick demo for show how send SMS can achieve under the enhancement of SEAndroid and containerization. So as you can see, this phone is running with Android version 5.11, and I developed a simple application to send SMS, and I will going to send this message to my colleague William's phone. Maybe it's too small to show, but it works.
Yeah, I got the mess.
So it's quite simple. So Android backdoor is one of the most complicated family, and usually perform multiple tasks in the list. So the malware writers use a variety of methods and technicals in their applications. So it's very hard to measure the effectiveness of SEAndroid and the containerization in addressing Android backdoors. So if SEAndroid enabled, so normal backdoors have trouble to carrying out install itself into system directory, remove system applications, or access other applications' data. But it's still able to uploading sensitive information, download and install applications. So we have another demo to show get the contact information. It's from my phone. Yeah. Oh, got it. So if I click this one, you will see it lists all the contact information for the phone. So, however, backdoors can be hidden in room image by either legitimate OEMs or third-party distributors. So, as a result, this kind of backdoor has a super user privilege and it can accomplish any tasks without worrying about SEAndroid. This malware CoolRape is developed by one of the biggest Chinese OEM, CoolPad, and distributed in several models. So it can accomplish most of tasks in the previous slides. The function in the spyware and the bank Trojan can be found in Backdoor 2, but they have specific target. So they use social engineering to gather sensitive information like about the person, organization, or devices. And this information can be SMS log, location, login, and password details. So this is not the first time we found Android malware in Google Play. However, this spyware infested by Sophos is much more complicated than before. So first of all, this malware attempts to harvest Facebook accounts. Secondly, this malware takes advantage of social engineering to be as a popular game and attracted 500K to 1 million installs in Google Play. Moreover, it utilized a framework named Monogame to creating cross-platform applications, which means the same malicious code can be published in iOS, macOS, Linux, Windows, even PlayStation 4. And it makes reverse engineering very difficult because it loads code dynamically from the website. So it also claims only few permissions to make them less suspicious. FakeAV and Ransomware report fake alert to scare victims to pay money. It has two scared functions. So the first one is to lock up device with a pop-up that frees out all other applications. So it needs either wake up or system alert window permission. The second one is trying to encrypt documents, pictures, audios, videos, and it needs read and write external storage permission. So this example, you can generate a floating window as a pop-up by setting specific flags. And it uses a system alert window permission. So the next one I'm going to show you is the simple lock ransomware. It uses the wake lock permission, and it can survive in SEAndroid and containerization and cause the damage to personal information. So make the video for it. As you can see, this one is washing. Maybe it's too small. Maybe make it small. Better. Sorry. Replay it. So you can see it's open a PDF file, Sophos report, and I started this ransomware. It's Russian. And I'm trying to open setting. No, it's pop up. Other application doesn't work. So sorry, another video. And if I want to try to open this PDF file again, it gives me an error because that PDF file has been encrypted by simple lock. So as a result, we can see that ransomware may not access the sensitive information in the secure container, but the behavior of lockout and encryption will seriously decrease the usability of your device. And you can only be removed by rebooting safe mode or performing a factory reset. So the vulnerability have to be discussed case by case. Here I list two popular ones. The first one is the Samsung pre-installed Swift key risk. The over 600 million devices are affected by this significant risk, including the Galaxy S6. So this risk has two issues. First, it relies on HTTP to upload updating language file, which allow man-in-middle attack to modify the language file. Second one, this pre-installed keyboard allow attack to execute the code remotely as a system user. So if once this flaw is explored, so the attacker can remotely install applications, even dropping incoming outcome messages, steal sensitive data. So finally, the attacker can turn this legitimate application to an actual key lock spyware. Therefore, it can break both SEAndroid and containerization. So this year, the most famous vulnerability is stage fright. So it affects the versions from 2.2 to 5.1. The stage fright is not only for playing media files, but also generate thumbnails and extract metadata from media files. So attackers can send MMS or web page that contain the customized media file to trigger this vulnerability. Or it can be triggered by when the user views the thumbnails, including the malicious MMS. So again, the stage fright has system privilege too. So this table, concluding by Joshua in Black Hat 2015, from his research we can see the SEAndroid cannot mitigate stage fright. The only challenge is ELSA. So in the real world, the number of looted devices is greater than our expectation. So a study shows that 25% mobile users looted their device in China. The benefit of looting device, it can be install root application, boost phones or battery life, or you can remove pre-installed software. So as a result, it comes no surprise that the malicious rootkit is being so popular, and bootkit, like an old boot, can infect 100,000 devices. So in the future, so in fact, none of security enhancement address the core issue related to Android permission model. So as a result, Google introduced a new permission model in Android M, version 6, that allow users to choose what permission an application can access at runtime. But we believe in the next 12 months, the uprising trend will continue to dominate Android malware attack. And the Android malware are getting smarter and aiming to generate more profit. And they will continue using the social engineering and Android fragmentation. In conclusion, I will talk more about Android M, attack vectors, and the vehicle and the variable-based malware. So Android M borrowed the idea from Apple. With Android M, permissions will be grouped to make review easier. And the user has ability to view and edit the given permission for applications. So however, the application can still use old permission model, and there is no reviewers in Google Play and third-party stores like Apple. And Android fragmentation is another big problem. And we will see more attack vectors like Google Play Store, third-party store, rooms from either legit or third-party distributors, spam, MMS, and the internet. And we believe internet will be the next big threat. And we are going to witness there is a real possibility that vehicle and variable-based malware in the future, especially ransomware. So we prove that simple lock ransomware has infected, can infect a smartphone and a linked smartwatch. And because the variables and the phone are meant to sync seamlessly and smoothly, any update will be pushed to both devices. So we believe this kind of attack will appears in the next 2 years. So questions, answer.
So with that, we have plenty of time for questions. So if you can give me a wave. So I have a question.
Yeah.
Obviously, you said it was doomed to fail. I think you're probably right. How much do you think the changes in M will really impact this? Because the social engineering aspects won't change. Mm-hmm. And then the second part of the question is, what would you have done if you were in charge of the program to make it better?
You mean how can we develop the applications to make it better? Or?
Well, what the Android developers themselves might have done that would have addressed the issues that you saw.
I think this is a very difficult one for the answer, because in the real world, because we have seen a lot of fragmentation, it's hard to control at this side. So, for example, in the Google Play, I think it's getting better, but we still can see a lot of malware can bypass the Google policy, and they will getting more smart to infect the peoples. So, for example, they were using the dynamic loading to load the data, and in that way, Google have little chance to witness all the code, because there is no human witness this kind of behavior. Another thing is like they will using the IP address checking to bypass the Google bouncing verification, because they check the Google IP address for the dynamic, that kind of simulation. So without human verification, it's really, really hard for them. Yeah.
And any questions from the floor? We still have just a smidge of time. There being none, I think what remains is to thank our excellent two speakers, Roland and William.
Yeah.